So I thought I'd do a little video now all about phantom dark energy and how it relates to the theory of quantum gravity that I've been promulgating for several years. Since this is an idea of dark energy that's recently attained some kind of a basis in evidence from the DESI experiment, the Dark Energy Spectroscopic Instrument experiment, um, where they found possible evidence for phantom dark energy. And phantom dark energy is a form of dark energy whereby the energy density formed by dark energy is increasing over time. Whereas this is really exactly what we should be expecting to happen. We should be expecting the energy density to be increasing over time for dark energy, because what I predict is that dark energy is just all the energy that's been released by all the stars in the universe since the beginning of the universe, right? So you have all this light being emitted by galaxies, by the stars in galaxies, and hence by galaxy clusters. So galaxy clusters move apart because light is building up between galaxy clusters, and the radiation pressure from the light is pushing them apart. So, really, what we should be expecting from dark energy is that, yes, the energy density is always increasing when it comes to dark energy, because there's always more energy being outputted into the universe. Stars still emit energy. There's still stars shining, obviously, in the in the night sky. Those are all emitting light. The light is, some of it's making out to these recesses between in intergalactic space between galaxy clusters, and the radiation pressure from the light pushes galaxy clusters apart. So this is why we have an expanding universe. This is why the universe's expansion is accelerating. It's because light energy is just getting trapped between galaxy clusters. So I mean, the mode by which the light is being reflected between galaxy clusters comes down to electron densities, and the theory that I've tried to advance, which is the gravitational fields are electron densities, basically, or secondary fields of electrons, which interact with other particles of matter, creating the effects of gravity. So one of the effects of gravity that we're talking about is obviously the cosmological constant, the expansion of the universe, the expansion of space. So what's happening is that this light being emitted by galaxy clusters is spilling out into these recesses between galaxy clusters and is being reflected by galaxy clusters. And there's causing radiation pressure to have an effect, and to cause this radiation in itself to be filling up space and pushing against objects and basically pushing galaxy clusters apart. So that's what's going on with dark energy. I thought I'd just keep this one quick. So yeah, the dark energy spectroscopic instrument experiment, DESI, and phantom dark energy seems like it's a very good fit for those data sets. Yeah, it wouldn't surprise me very much at all, because this is really what I'm thinking dark energy is, that it's just ordinary radiation, really, emitted by galaxy clusters, pushing apart galaxy clusters in these recesses of intergalactic space. And yeah, that's why we have an accelerating expansion in the cosmos. Oh, there's another mechanism that's also involved in my theory of quantum gravity anyway, which is to do with electron densities causing gravitation, which is that electrons absorb and emit photons all the time. So this is where the cosmological constant comes from. This is where the background energy in the universe comes from, the background radiation. So we have electrons absorbing a photon, say, in one part of the universe, tunneling to another part of the universe where they emit a photon, and the sum of these photon emissions gives us the vacuum energy of space, basically. Gives us this reason why space seems to be permeated with radiation, and it seems to be also why space spontaneously gives off radiation. It's not really the spontaneous emission of any particles. It's certainly not any new particles popping into existence, I don't think. I'm very skeptical about this idea of particle antiparticle pairs popping in and out of existence. And in my model of quantum gravity, there is no antimatter. So I don't believe in antimatter, which a lot of people out there might disagree with, but I have, I think, pretty solid, good reasons for believing that antimatter is a phantasm, that it's not what we think it is. And yeah, I don't believe in particle antiparticle pairs. popping in and out of existence and annihilating with one another, and sometimes a photon gets released, this new photon getting released into space. I don't buy any of those sorts of ideas at all. And I think it's just energy photons being transmitted around the universe by tunneling electrons. And that's fundamentally what's going on. But yeah, as far as dark energy is concerned, this it lends some credibility to my hypothesis, I think, since in the model of dark energy that I would expound, which is, I guess, associated with phantom dark energy, or similar to phantom dark energy. Yeah, the energy density should always be increasing because stars and so on emit light. So there's always more light entering the system. There's always more light spilling out of galaxy clusters into these regions of intergalactic space. And yeah, that's why the energy density is increasing. Just to not be too long-winded about it. So quick video for today, just a bit on dark energy and phantom dark energy, and a little bit about the cosmological constant there. And I hope to see you all soon. I hope you enjoyed that. Thanks for watching. Bye.